So I wanted to do a quick guide on how you can actually set up Athina and how you can build your tests and implement your assignments. And for that, I'm going to be using some of the examples that I have created for a class of mine, and this way I can show you how you can use it to develop your own tests. For the most part, I'm assuming that you already have went through the actual installation guide here, you cloned, and hopefully you're using the one-click run so that you won't have to do much work. So there is already an instance of Athena that is running here. So I have a database assignment that I will be using as an example on how you can develop your own tests. There is many ways that you can go about doing this, but this is just one aspect. And if you need more assignment examples, I have those online too on the Athena repository. So here's a SQL assignment. The students are supposed to solve a series of questions that they have to do, and for that assignment, they're expected to use the employees file. So I have an actual file for them that they have to use, which is this one. It's just a SQL, so they have to set up their own database. They don't have to, because the testing could actually take care of that for them. But if they wanted to do it locally, they would typically install that file, set it up on their server, and then they run the queries the way that they want to run those queries. So in my case, what I'm providing to them is the SQL file, and then they have to download these files and create their own repository where I can later access it and search for it. To show you how this would look like from my perspective, so this is one of the assignments that they have to do. So display the first name, last name, and latest salary for the top 10 higher salaried employees. So in this particular case, the student would have to type whatever query they need to type to solve this problem. And once they have a repository, they typically submit that repository to me. And once they submit that repository, I get a list of all of the names. Let's see if I can hide that. I get a list of all of the names here and their respective scores that they currently have. So this way, again, this is a tool for formative assessment, so I get to see what's their progress at any given moment in the class. And clearly, the higher you up on these, the better you are in solving the problem. Now, if you click here, instructors and students both access this. I can actually access the file that Athena gives back in terms of the test report. So in this case, I can open this and I can see what the test results are. So this is the test that I will show you how I went about building, but you can see here the student sees that there's a database that started. It executes all of these queries. For each one of these SQL files, there is an output. I use a difference in terms of the number of lines that are different, and if none of them are different compared to my code and their code, the test pass. Otherwise, it doesn't pass. And then there is a second type of test that is an efficiency test that I'm looking for differences in time. And again, that's a statistical problem. This is something that the student may need to look at and have to improve their SQL code. Maybe they did something inefficient, so these are opportunities for them to actually correct that. So this test case has two tests. One is about correctness. The second involves a correctness part, but also more importantly, efficiency. And as you can see, there's test weights here. So there's a 0.8 and 0. So 80% of the first test, 20% of the later test, the grade comes from. And this is maxed out at 80 out of 100 total points. The rest of it I'm assigning manually, depending on what I see. So this is what we are going to be looking at. So the first task, notice that the student actually has to submit the URL here. And also, I do not have to submit the test report or even the grade for that matter to Canvas. So it's not something optional. If I wanted to access that information just me without actually sharing that information with the student, I would go to Athina, and this is the server that I have for my assignments. The Athina web interface is the one that provides you with access to all of the assignments and repositories that you may be running. And here I would look at the SQL one, and you can see I have access to the assignments that were graded, which one was graded, and also access to the test report in case I wanted to view it here too. There is also access to most report and force the run in case you are using any of that. So how do we go about building a test? And here you see one of the solutions that I have for a simple query. So once you have that solution ready, you have a code that you can compare against that of the student. So that's fairly standard. Most of us actually do that. So the first task that you have to do is actually develop the tests. And since I mentioned that there's going to be two tests, I need a file that is going to do the correctness check and the other one that will do the efficiency check. So the correctness check is a fairly straightforward bash script. You don't have to use a bash script, but ideally, whatever script you're using, you need to be able to produce any number of lines, and the final line needs to contain an output of the actual grade scaled between 0 to 100. I find bash scripts useful for really simple tasks, but you could use Python or virtually any other language that you can imagine to build your tests, whatever you are more comfortable with. In my case, I use bash in this example. And for the most part, the code that you have to develop is fairly straightforward. So you build your code as if you had access to the student assignment, and Athina will pass you two parameters. The first parameter is the directory of the student code, and the second parameter, which you can see here, is the directory of the instructor code. And the instructor code, of course, includes this tests directory that I'm currently at right here on the left side. So that instructor code directory contains my tests, any other files that I may deem necessary for my tests to operate. In this particular case, you'll see I actually have the solutions to the assignment. And other than that, the rest of the test is just a simple loop that just executes the student's query SQL, my query, the corresponding one, so Q1, Q2, so this file keeps iterating, Q1, Q2, Q3, and then I'm using the diff to actually store the differences, checking whether there are different lines, and whether there are different lines, I'm outputting to them whether they passed or failed, depending on the output. And after that, I'm just using a scaling parameter and exporting the actual result between 0 and 100. So that's the script that can be developed fairly straightforward on your computer, and you have the option of running this. If I navigate to the directory of the assignment, you can see here the tests that I have. I could use the test correctness script and test the actual results. So I would say that I can actually use the same directory for testing purposes. So I could say, oh, the student directory is the one that I'm currently at, and the instructor directory, which would be the second directory, whatever that directory would be, it's also the one that I'm currently at, and this will execute the script for me. Now, it's not going to do anything because I don't have a database that is actually online. So instead, I'm going to get passed for all of the parameters, but I got an access denied for these databases. What happens once we have our tests? So the tests, we build the tests. We know that we can test the student code and contrast and see if something is passing or failing. So what would be the next task to incorporate things to Athina? So the next task is just setting up the Docker file, which is for the purposes of Athina, it's the specifications that you need your file system to have in order to be able to execute, to be able to run your tests. And in this particular case, yeah, you can go ahead and ignore these comments we can ignore. So effectively what you see here is the Docker file. If you've never used Docker before, it's fairly straightforward. All you need to do is add the default distribution that you want to use or whatever setup you want for your container. In this case, I'm just using the vanilla Ubuntu 18.04 version. You need to add to that image any files that are necessary for your tests. So this is highly specific in this particular case for the MySQL database, that I need to add this file in, which is the database SQL file, in order to set up the database ahead of time before I need to run the tests. Now, typically for tests like for programming languages, you shouldn't need any of that. The student directory and instructor test directory are mounted when this image would be running, so you don't need to actually import your test files into that. That's done automatically. You're past the parameters of where that directory is. But in this case, I needed to add this image. And as you can see, other than that, all I have to do is add all the requirements for my tests to run. Now, typically, if you are not keeping track, so if you are developing your test code and you're not keeping track what you're using, like BC, and you don't remember if BC is installed by default on Ubuntu, when you're building your Docker image, as a test, you'll see things failing, and then that's something that you can add. But let's say you didn't know that. So you'll go about building, update, add any installations that you need to install, start the MySQL server, assign a particular root and password name. So as you see, is a fairly default password that I'm using, but again, this is a container, so I don't have to care about what happens to the database. As long as the students cannot guess the password, I'm not really worried about that. And other than that, I'm just exporting or importing, I guess, the database file, the database SQL dump into the database. And I have this final statement here just so that I can see that the database was imported, right? So I'm gonna get to this parameter right here, but I'll show you what happens if you were to try to build this image. So this is where the Docker file is, and if you wanted to just test to see what is the state of the Docker file, you can just call docker build, and this one is going to execute all of my statements all at once. If you never used Docker before and you're wondering why all of these statements under one category, it's because when you execute run, the services that are built into that container do not remain executed in memory. So if I start the MySQL server, the moment this run sequence ends, the MySQL server will go offline, and it's not going to come up online until the actual container is run properly after that. So while I'm building the container, I need to do all of the steps using this end sequence so that I can make sure that all of this is executed in a stepwise fashion when this image is being built. So if the image is built successfully and there is no errors like this one, you know that pretty much Athina, when it takes that Docker file, it's going to build the exact same image that you have in mind, that you just built. And as you can see here, everything was built. I used the tag test for my case when I was building this so that I can call the tag test when I need to run the test. So in this particular case, I'll show you the next step. So the environmental variables that are passed by Athina are accessible after all of these run commands execute. And for whatever series of tests you need to run, the commands that need to be passed to Athina will go through this entry point sequence. So if you notice, what I'm doing here as the first step is I'm bringing up the database server. That's the database server that was built when we called the build command. So all of the build that we constructed, all of the packages that were installed here, that's going to just come online the moment we execute the container. And then after that, I'm entering into the test directory. So this is one of the environmental parameters that Athina passes to you when you need to build the test file. And I have a diagnostic here for my purposes. I want to list the SQL file so that I will see that there is SQL files in the test directory. I don't really have to do that, but I'm just doing it as a diagnostic method. And other than that, Athina will pass the following other environmental parameters. Test, which is the actual test command that you are passing through its configuration, the student directory, and the test directory. In case you're wondering what that test command is, I'm just going to show you quickly, and then I'll get back to this. So the test command is, in this particular case, is this command right here that I'm passing, and this one. It can be anything you want it to be, and as you can see here, you can just type whatever you feel like this command to be if you want it to have parameters or something like that. But in this particular case, I'm just using pass to load up that parameter, which is the test. And this is what Athina is going to do, is going to read this configuration file, which we're going to get back to later on. It's going to read the configuration file, and it's going to execute once the container using this test, and the second time it's going to execute the container using that test, that second one. And after that, it's going to pass, because that's the way that I have it set here in this Docker file, it will pass the student directory and test directory parameters. Now the test directory, of course, it's important because that's where the tests are. That's why I'm actually entering the test directory here, but also knowing where the student directory is important because that's where the student files are. So these are the two things that you know, some of the things that you need to concern yourself about. Now, if you were building, let's say, a programming language kind of a setup, I would typically remove this MySQL. I would just enter the test directory, just execute whatever the test is. Or if you expect the students will have incorporated tests into the programming code, you can just go ahead and directly enter their student directory and then just execute whatever test command you have in mind, like PyTest or Gradle if you're using Java or something like that. So assuming that this runs correctly, I have some test code that I use up here, commented lines, that I'm using just to be able to verify if everything is working correctly. And because I'm using multiple computers to test this configuration, I have different variants of that code. But for the most part, the first segment right here, it builds the test app, and that clearly has to be built only once. So that takes a long time to install the packages, but that takes, you know, that happens only once. And after the container is built, you don't have to be rebuilding it every time. So the command that actually will do the work of executing, and I can replace it with my test for this case, since we used test when we were building this. I'm just going to call this here, test. All right, so the command that actually executes the container that we have is this Docker command. Now, this is done automatically by Athina also, right? But if I want to run a test to figure out what's happening, it's useful sometimes to actually pretend that you are Athina and run these tests yourself. So you will say Docker run, and then you will pass manually the environmental parameters. So here you see the test as I would write it to Athina, the student directory where the student directory is, the test directory where the test directory is on the container, and then I'm mounting volumes from my local directories to those test directories inside the container, and that's what you see here. So I'm doing two different mounts for the test and the student directory, and finally I'm saying use the test container to execute this result. So if I run this, and I probably need my credentials, you'll see that it actually executes the container. It's starting the MySQL database server. So this is it for the Docker file. For the most part, it's a really straightforward process. Just pick up the image that you need, pick up the actual, any files that you may need to import, set up all the requirements, and usually the apt repositories have everything that you need in there. And after that, set up a command that can be used to take the data automatically from Athina. So The tests obviously have to be somewhere there, and then whatever parameters you feel like you need to convey to those test scripts that you have. Those are important. And those parameters, of course, will be conveyed on your test script on the order that you're passing it to them. So in this case, I know that number 1 is the student directory because that's what I said that it's going to be, and number 2 parameter is the test directory because that's how I passed it. If I did it in reverse, clearly that would be a different, then I would have to revert that into my tests too. So okay, so far so good. We have a test. We have the Docker file that just specifies what sort of environment we want to be testing things in. So the final configuration file that you need to do to work, to have Athena work, is the one that you are actually passing a bunch of parameters for your assignment, right? So here, in this particular case, the file that you need to work on is called Athena YAML. That's the default file that Athena is using to build, to look for configuration. And in this case, you're going to have you need to pass a bunch of parameters based on what you want this test to do for you. So for one, you need your Canvas authorization token. That's very easily obtainable through Canvas. You need to also specify the Canvas URL. So if your university is using a specific one, particular subdomain, you need to also pass this. In the future, there's going to be other platforms that I'm hoping to support, but for now, we're using Canvas here at Western, so that's the one that I have for this application. Other than that, you need the course ID and assignment ID, in case you're wondering where I found those numbers. When you have an assignment in Canvas, those 2 numbers can be obtained from this top part of Canvas. So course ID and assignment ID. So when you will have these numbers, you can just fill them in here. The next step is to specify your test scripts, and you can add as many as you want. You can also add whatever sequence of commands you want. So if you wanted, if you were using Gradle for some Java assignments, you could use that. If you're using PyTest to test things, you could call that, and with whatever other parameters you want. And of course, if on your Docker file later on you're adding the student directory and all of that is going to be added automatically. So I would anticipate that things will be added after these commands, environmental parameters and things like that. The second step involves having test weights. So you have 0.8 and 0.2, or you can change that. As long as they add up to 1, that's fine. And then, of course, the total number of points. If you want Athena to give all the points based on tests, you can switch that to 100. Otherwise, 80 is fine. Whether you want to enforce the due date, and the due date is actually obtained by Canvas. So Athena will just pick up the due date from Canvas and use that as the default date. If it's not enforced, then all of the assignments, even after the due date, will be checked. If you are using MOS to check for plagiarism, you could specify the language. Here I have SQL, but MOS doesn't support SQL. I just have it here as an example. You can also pass a MOS pattern for the files that you want to be checked. So those are the ones that will be pushed against the MOS repository application. After that, you need a set of Git credentials based on whatever Git platform you're using for assignments. So in this case, I'm using the local GitLab copy for students to submit their assignments, and I'm expecting them to build private repositories. But of course, students can use GitHub or anything else. The reason why you have to specify what sort of a Git repository you will be using is because this is a security risk. In case you're wondering, the username is your username, whatever you're using on that platform. And for the password, you don't have to use your actual password. Almost all platforms support a read-only authorization token that you can obtain and dump here. So that makes things fairly straightforward. Other than that, there is a bunch of other configuration things here. So you see we have the same URL limit whether we have group assignments or not. In this case, I'm expecting every student to have a single unique URL that is the repository. How often to check for plagiarism, and it's done once in a day so that we won't be flooding MOS with multiple requests, but if it is done once or twice or whenever, that's part of the information here. Whether you want to submit to students the results as a file, there is an option to submit things on Canvas as a comment, but clearly If your tests are really verbose, then you don't really want to submit them as a comment. It's better as a file. The maximum file size, the test timeout, so how long should the container run and when it should be killed off. Sometimes students write infinite loops in their code that never terminate, so eventually we'll have to terminate that code. So usually I set it to 60 seconds or 120 depending on the type of application, and I have some additional parameters here for myself. So this is more or less how you set up the YAML file for Athena. So once you've done this, all of your code is virtually ready to be executed by Athena. So what you're gonna have in your repository once you have all of your files is you're gonna have a list of the tests inside the test. So the tests will be inside the tests directory. You'll have the Docker file that describes how the configuration of the system that was built. And in this particular case, you'll see I'm building something for signature-based detection, so I'm having a completely different setup, and the tools that have to be used to make this work are different. But for the most part, the entry point literally just enters the test directory, executes the tests, and passes a parameter, the student directory and test directory. So test directory, Docker file, and then the Athena YAML file. So once you have that repository ready, and I'm assuming you have a private repository that students cannot access your test cases or even your solutions to your code, the next thing to do is to actually tell Athena where to find that test repository so that it can start testing, running your test cases. So here's where the web interface comes handy. If you're not using the web interface, you have to set up cron operations for every single assignment that you have, but the Athena web actually takes care of that. So you can create a new assignment, right? And here you can specify the name for the new assignment, whether it's active or inactive, and then you specify where your Git repository is. Okay. So once you add this, Athena will pull the Git repository, and if it's successful, if you click View Directory, you'll be able to see your Git repository here. Now, what you're also going to see is that a bunch of other files are created by Athena in order to manage. So there is the repositories for each one of the users, which contains the code of the different students, and that's stored here. It's automatically updated whenever a student sends a commit. The other thing that exists here is your test cases, which you can see them here, different test scripts and things that have been submitted. So all of that code is still here. So if I click on the test correctness, you'll see my original code here. And other than that, you'll see I have the Docker file, which is here. You have everything correctly set up, meaning your Canvas IDs, authorization tokens are okay and everything. If you click on the View Users, and it usually takes about a minute for Athena to pull everything, but the first time that you execute this, if you click on the View Users, you'll be able to see all the users, whether they submitted a repository, whether they were graded, what was their test report. If you want to force a rerun for a test for a particular student, you can do that. You just click on that, and you can see now this changed to a yellow. So this assignment is going to be checked again in about a minute or so from Athena. The other things that you have access to is the log file. So if I click on the view log, it will pull the log file for Athena. And this is rotated, so clearly this is not the complete log file, but this way I can access information about this particular execution. And if I refresh this, you'll see eventually that I'll be able to see Athena executing live the code. And if you remember, I just requested that one of the scripts needs to be executed again. So you'll notice here that Athena just started executing. If you have the debug messages on, you'll see what Athena is passing here. So there is a sequence of directories and things, exactly like we did manually on the command line. So this is done automatically by Athena. You'll see now it's running the efficiency tests. So the first test is done, the second one is being executed now. And of course, this can run in parallel. So Athena supports multiprocessing for its user. So if multiple users submit the same some updates, they commit some code, those will run in parallel if you set it up to do it that way. So that's all about using Athena. I hope you have a better understanding on how you can set it up. And let me know if you have any feedback or any recommendations for future videos and tutorials.